So I'm back here, and we have a tree. We're going to try and draw a picture. This is problem number, I shouldn't say it, because the fake test that I gave, you probably won't have access to, because you're not in this class, which means I should probably try and describe these problems a little bit. So, okay, we have this tree, right? Okay, so here's a tree, and we're going to try and figure out how high it is. And technically, we're going to call this the top, and we'll make our perpendicular height like this. Oh, okay. So this is not the world's most perfect drawing, but this bit is what we're looking for. We're looking for the height. And somehow, amazingly enough, the people who were in charge of figuring this out managed to get a couple measurements. One was from here to here. And here's, oops, this is like the biggest one I've done. Okay, so we know that this is an angle of 25 degrees, and they also took another measurement from here. Ooh, okay, from here to here. This is 45 degrees. Here's 80 feet. Incidentally, this is a real surveying trick. And this right here is the bending of space-time due to the tremendous gravitational mass of the acorns in the tree. So this is all that we're getting here. We need to figure out how high the tree is. Well, a couple things. The drawing's not perfect, and they're never going to be, and this is why I'm one of the few professors left, it seems like, who's not a big deal with graphing or graphing calculators. Yeah, they have their place, but drawings can only give you ideas about how to look at things. And here's the big idea here for this one. 45, 90, that means this has to be 45 degrees. If this is 45 degrees, I mean, think about the tangent of this. If we're looking at this triangle right here, so here's 45 degrees, here's 45 degrees. I got h here. The tangent of 45 degrees is equal to 1. So the tangent is this divided by this. So we'll call this box. This is h divided by box. Whatever box is, better be 1. This is obviously h. Okay? And this gives us some good stuff here because, well, that means that along this entire bottom, this is 80 plus h feet, right? And we know what we have this, we also know this squared plus this squared equals this squared. I'm not sure that I want to use that. I think there's actually something easier to use. There is. How about this now? I have this bigger triangle right here, and I'll do the fake drawing of it right here. So here's the big triangle. This is 80 plus h. This is h. This is 25 degrees. The tangent of 25 degrees is equal to h over 80 plus h. Yeah, this is going to work out. I can convert this into a number by using my trusty calculator. And okay, and tangent of 25 degrees, I notice I'm in degrees, is 0.466. So to really confuse you, I'm going to take this, bring it down over here so I have some room. Tangent of 25 degrees is 0.4663. I'm just going to approximate it as 0.466 because I believe they want it to the nearest foot, and that should be close enough. This is equal to h over 80 plus h. I'm going to multiply both sides times 80 plus h because I know that h isn't going to be negative 80 and I won't be multiplying by 0 because negative height would be possible in a strange world. So from here we have 0.466 or 466 times 80 plus h is equal to h. 0.466 times 80 is 37 and 30. So this is 37.30 plus 0.466h is equal to h. I'm going to subtract 0.466h on each side. Let's see. 466 plus 1. We're going to get, bringing this over here, we're going to get this 37.30 is equal to 0.534H. Sorry that I'm running out of room here so badly. This is, in pedagogy class, we're taught about board technique, and mine's kind of bad sometimes. Anyway, I'm going to divide those sides by 0.534. And let's see, so we'll have H is equal to, in 1 second. Upside down. I have 69.85. And I believe they wanted to the nearest foot, so I'm pretty sure that's 70, that we would say that this is 70 feet. Actually, I'm sure. Not really. So, pardon the spasmodic board work. Okay, so this is a good problem, and this is going to be pretty similar to something you're going to have to work on your exam. So we have one more for the fake exam. And actually, let me get the t-shirt of disgust. Let me see how hard it is, because we only got about 2 minutes left on this reel. Yeah, well, okay, so maybe we'll go a little extra on this one. It's not hard, but I don't want to rush it just because we have to flip tape. Okay, so we are given that tangent of some angle x is equal to 5/12, and we're in the third quadrant. That is that this angle x is between this, pi and 3 pi over 2. So we need to draw a picture. And we're in the third quadrant, which is right here, so I'm just going to draw this generic picture here. And here's our angle x. And this is the picture we're going to use. Tangent x is y divided by, so this is y right here. Here's y divided by x. We could do this, 5 and 12, but we would be so wrong because this is -5 and this is -12. -5 divided by -12 is still 5/12. That makes this 12 squared plus 5 squared is 144 plus 25 is 169, and actually, technically, it is -5 squared, which is 25, -12 squared, which is 144. The square root of 169 is 13 on a good day. So this is 13. Okay, so this is our picture. What are we supposed to figure out? Oh, we have more information too. Breaking news. We are also given, we're going to need another picture. We are given that the sine of some angle y is equal to -3/5. So this one is going to take a while. We're going to switch reels, and I'm going to draw another picture so the board comes out a little cleaner. We'll be back.